Hi, friends. It's Mr. Rogers, and we started last week with the water properties, and we started with in class we were just really almost exclusively talking about polarity and how polarity worked. And in class this week, we're going to be looking at water properties. And so, if this is something you already wrote down, that is completely fine. If you already filled out the notes, it's completely fine. I'd still listen just because it's always good to hear from my voice and hear what I find most important and maybe some examples that I give outside of what's on the actual PowerPoint. So, side note, if you hear baby in the background, I not really apologize, but there's a baby in the background. So you might hear some cooing or you might hear some crying. I don't know which one. We'll see how this goes. So water has a lot of unique properties that make water special. Water actually acts like nothing else in the whole entire universe. Water acts like a whole new kind of molecule and doesn't follow any rules that we would assume it would follow. And that's because of something called polarity and hydrogen bonding. Polarity, what polarity actually is, kind of like when you think of North Pole and South Pole, polarity means that there's opposites on either end of the molecule. And in this case, a polarity for us in water is one end is going to be positive and one end is going to be negative. And this positive negative end affects everything that water does and how it interacts with everything. Because as it's polar, it now can actually make bonds or kind of like attractions to other things that have a charge as well. And so water interacts with the surroundings around it. And if it doesn't want to interact with water around it or other things, then it'll act differently. We'll kind of take a look at that. So here's the page about polarity. H2O is a neutral molecule, but because oxygen is sharing electrons with hydrogen, yet sharing isn't the greatest word, oxygen allows hydrogen occasionally to borrow its electrons, while hydrogen is trying to share. Oxygen ends up being just this huge bully and it holds all the electrons to itself. And so oxygen becomes very negative and hydrogen becomes very positive. And now, as we know, opposites attract. So anything that is negative is going to be attracted to this end of water, and anything that is positive is going to be attracted to this end of water. And that's what hydrogen bonding is. It's when one negative of one thing is attracted to the positive of another thing. And you could see it here. There's one water in the middle. This H is positive. Well, it's attracted to this oxygen up here that's negative. And this H is positive. Well, it's attracted to this negative over here. And these two negatives, or this negative of the oxygen, are attracted to these positives of these hydrogens of the other waters. And so it allows water to interact with itself and also allows water to interact with other things. And that's where we get to the main properties that we're going to talk about this week. The first one is cohesion. I like to think of like they're working together. Cohesion is when water sticks to itself. It's trying to stick to itself. It's trying to stay with itself. And so water molecules attract each other. You've seen this in water droplets. Water is attracted to itself and doesn't spread out. You might also see in a water droplet kind of break apart and kind of spread out. Well, that's because it wasn't attracted to the water anymore. There was a bigger attraction to whatever surface it's on. So that's why we put wax actually on our cars. Is wax is something called nonpolar, which we'll get to. Nonpolar means that it does not have a charge and does not interact with polar things. And so when water hits the car, it just beads off and falls off really, really fast because it can't attach itself to the metal of the car. So the definition of cohesion, the actual definition is water molecules attract each other. Another example we're going to look at this week is insects walking across water because of surface tension. So if I could spread out my weight enough, if there was more of a connection between the water molecules than the pressure I'm putting down on the water molecules, then I could actually walk on water. For a human to be able to walk on water to spread out its weight big enough, we'd have to flatten our foot out by an 8-foot by 10-foot box. So obviously our feet aren't that big. So we're not going to be, fortunately, we can't walk on water ever. But bugs, they can out their weight enough and they could actually walk on the surface of water because their weight is not breaking the surface tension or the cohesion between water molecules. Cohesion is also why water molecules go up a tree and we'll talk about that more tomorrow. But water will actually connect to itself, and it'll kind of like ladder itself up a tree from the roots to the leaves. And we'll take a look at that tomorrow. We're going to do a celery demo in class, and we're also going to do a little bit of a talk through online about how that actually works. Adhesion is water molecules attracting other molecules, or water molecules attracting other molecules that aren't water. So adhesion, I like to think of adhesive glue. That word in Latin means to glue two separate things together, or two different things together. And so adhesion is when water glues to something else. Now, again, this is another example of why water droplets form, is because water cohesion, or sometimes water sticks to things and makes water droplets on different things. Another example is this: if you ever had like something wet, or like a cup or something on a wet table, and you set the cup down and you try to pull it off, and then there's a little bit of suction, that's because the water is gluing the cup to the table. It's kind of involved with getting water up a tree again. Like I said, we're gonna talk about that tomorrow. But this allows the water to stick to the tubes inside of a plant to allow it to be able to climb up. Less dense to the solid. This is a really big one, and one we kind of forget to talk about a lot, because it just means that ice floats. And that doesn't seem that important for living things, but there's a lot of different features to this that without it, we wouldn't be alive right now. And one of the biggest ones is that if ice sank as it froze, then ice would crush everything underneath of it as it sank. And so all life forms that started in water would have died off because they would have been crushed under this giant sheet of ice that was sinking through the water. Now, another important one is now, obviously, it's floating on top. It's insulating lakes. It's insulating bodies of water to allow the water to stay warm enough for living things to live down there. For example, in Lake Michigan, the ice freezes over on top, but underneath, a couple hundred feet underneath that ice, it's 60, 50-ish degrees, and fish are living down there, and they can stay warm. High Pacific heat is the amount of energy required to change 1 gram of water by 1 degree Celsius. Water has an incredible amount of high Pacific heat. It's like 4.12 grams per calorie. Basically, what that means is water wants to resist temperature change, and water resists this change incredibly well. And so when water is, say, in a pot boiling, it takes a long time for that water to boil because it's resisting a temperature change. It is resisting that change because water rather be connected to itself and wants to hang on to each other than to keep separating out with more increased temperature. This is also a big thing with lakes and oceans and temperatures in our air. The water does a really good job of maintaining heat or maintaining a cool temperature. And you see that with temperature trends even in northern Michigan. For example, in the summer, the lake is cold still. It's taking a long time to get the lake to warm up. And so Traverse City is usually colder than Kalkaska because the lake is absorbing all the heat from the area. Then in the winter, the lake is warmer because it still has that summer heat, and it's pumping out heat into the air. So that means in the winter, Traverse City is usually warmer than Kalkaska is because the lake is kind of artificially warming the air around the lake. This is also a big reason why we have lake effect snow, and we'll cover this in the next couple of days. But this is, again, especially since it's towards the bottom where I put it, kids tend to forget this one, but it's super important. And it's kind of connected to heat of vaporization. This is how much water is trying to resist temperature change again. And this one's more dealing with going from water to steam. And so this resisting a change from going to water to steam is a big player in how we actually cool our bodies down. It's why we actually sweat. And so when you sweat, you put water on your skin, and it absorbs your heat from your skin and your body and then evaporates off, leaving behind salts and things that make you smell and whatever. But it's taking the heat with it. So when you Sweat, that heat is getting pulled by the water and it takes the heat with it as it evaporates off, cooling you down. It's why a dog pants. A dog is panting because it has all that water on its tongue and it's pulling the heat off of the tongue and the dog cools down. And then finally, universal solvent. Water dissolves anything that is polar. So if it's a polar item, water can dissolve it over time. And most compounds and organic molecules are polar, and therefore inside of us, they're polar. We're mostly polar as a living thing. And so the water's ability to do this allows us to use water as a base, almost like environment for everything living. Inside our cells, it's a very watery environment. And we use that ability of water to diffuse things and to dissolve things to allow reactions to happen that make us live. And so universal solvent is really important. Obviously, it's also cool it's universal solvent because we can use water to clean up items around our house. We can use water to make lemonade, to dissolve salt in. Everything water dissolves or can break down is because it's a universal solvent. So those are the water properties. This week, we're going to try to memorize and get all of them down, make sure that we're experts in all of them. And I hope that that was a good start, and I hope that we can become experts in all of these. So thank you guys, and have a wonderful day.